It's Abhishek, and today I'll be talking about functional groups. Functional groups determine a compound's chemical and physical properties. Functional groups are defined by their characteristic arrangement of atoms. It is also a part of a molecule where most of the chemical reactions take place. Now we move on to identifying functional groups. So in determining a functional group, you need to know the structure and where the bond occurs, as well as the name. So first we have alkene. Alkene usually has a double bond with two carbons, as seen here. So the example of this would be a double bond between two carbons. Second one, alkyne. Similar to the first one, alkene, but has a triple bond instead of the double bond, as seen here. The third structure name, ether, has carbon with a single bond with oxygen and another carbon. And what you would circle in this one is the oxygen. The fourth functional group is amine. Amine is nitrogen, which has a single bond with three other carbons, as seen here, but you would only circle the nitrogen with three bonds with carbon. Now the fifth functional group, is alcohol. It's carbon, and at the end, a bond with OH, which is oxygen and hydrogen. The sixth functional group is aldehyde. Now, aldehyde usually has a bond between carbon, a single bond between carbon and hydrogen, and a double bond between oxygen, usually at the end of the atom, at the end of the functional chain. As you can see here, you would circle C, double bond with O, and H. The next one, amide, is carbon with a single bond with another carbon, a single bond with N, and double bond with oxygen. And what you would circle in this one is carbon with a double bond with O and a single bond with N. The next functional group is ketone. This just has a carbon with a double bond with oxygen. So you would circle carbon and the double bond with oxygen. The next functional group is carboxylic acid. Carboxylic acid is C, which has a single bond with C, which is carbon, and a double bond with oxygen, and another single bond with oxygen and hydrogen. And this usually occurs at the end of the functional group. So in this one, you would circle the C, having a single bond with oxygen and hydrogen, and the C having a double bond with oxygen. The last functional group is ester. Ester is a chain where C has a single bond with O as an oxygen, and C has a double bond also with O, which is oxygen. So in this functional chain or group, you would circle this C carbon, double bond O, and single bond with O.
Today we'll be looking at the three types of naming: alkane, alkene, and alkyne compounds. We'll be using the IUPAC system. And first of all, we have to know what type of bond, what type of compound we're dealing with. And we can determine this through its bond. If it has a single bond, it's going to be alkane, double bond, alkene, and triple bond, it's going to be alkyne. And based on the bond, you know how to name it. So, for example, let's look at this. We have one carbon over here. So the number of carbon atoms we have is 1. So the prefix is going to be meth. And it's all single bonds, right? So its name is going to be alkane. And because its name is alkane, we're going to use the suffix ane. The suffix is always going to be the last three alphabets of the name. So alkane, it's going to be ane. Alkene, it's going to be ene. Alkyne, it's going to be yne. So over here, this one has 2 carbons, so it's going to be 2 prefix eth. And since it's alkene, it's going to be 2 ethene. This one has triple bond, and it's 2 carbons, so it's going to be 2. It's going to be ethyne. And let's look at this example over here. In this example, we have substituents over here. So when we're dealing with substituents, we have to order them so that they're in the least number, if that makes sense. Like, if we count them off from here, 1, 2, 3, 4, 5. The substituents are on 3 and 4, which is fairly high numbers compared to 1, 2, and 3. So we would rather have lower numbers. So we would write the order the substituents are in. So it'll be 2 and 3. So we write 2, 3, and then we would look what type of carbon we have over here. We only have 1 carbon, so it's going to be number of carbon atoms 1. It's going to be meth, and we always end it with YL, and we get the di because there's 2. There's 1 over here, 1 over here. And then when we finish this off, we write the parent function, so it's going to be 1, 2, 3, 4, 5, 5 carbons. And this is all, and we have a double, let's ignore this. And they're all single bonds, so it's going to be pentane. And if we were to have a double bond over here, the naming would be affected because we would always count from where the double bond is. So the double bond is at 1, so we'd write 1 over here and dash, and we would always start counting from the double bond or the triple bond. And this would change from ane to ene because of the suffix of ene due to the double bond. And this is how you name alkane, alkene.